In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
In space, threats can come from any direction. Meteors from deep space, invisible but deadly bursts of radiation from the sun, otherworldly landslides from above, and Marsquakes from below.
Outer space is the last place you want to be as a human being.
What makes fire more deadly in orbit than on Earth? What happens to someone exposed to the harsh extremes of outer space?
The saliva, the blood goes from a liquid state to a gaseous state.
Buckle up and prepare for space disasters. The year is 2030. A crew of astronauts simply hits the up button in a space elevator. The elevator will bring them to their spacecraft, which will meet them in orbit. They're grateful they don't have to risk the controlled explosion of a rocket launch.
We can now create carbon nanotube fibers that are stronger than steel. And believe it or not, they are strong enough to keep a space elevator afloat in space so that you can literally climb your way into the heavens.
The 60,000-mile cable is attached to the docking station that revolves at the same rate as the Earth. Just like a geosynchronous satellite, it stays over a fixed spot on the ground. A space elevator would be any astronaut's dream. But the space elevator dream can also turn into a nightmare.
The space elevator has to be anchored to the Earth. But what happens if you have storms and all of a sudden the moorings begin to snap?
With the cable still attached up in space, it will start swinging wildly, striking objects hundreds of miles away in any direction. It's also possible that some type of guidance computer or thruster problem could knock the platform in space off course, snapping the cable at the top. If it happened while a crew is going up or down the cable, they would be in for the last ride of their lives. And the 60,000 miles of cable hurtling toward Earth is long enough to wrap itself around the planet almost 3 times at the equator, creating havoc over a wide area.
It would be not only disastrous and dangerous for the people involved, the kinetic energy of something like that whipping through the atmosphere would be a menace to navigation. So it's going to have an inherent danger in it that any human system has.
This is just one of many potential disasters facing future space explorers. Living in space will also involve grave dangers. Colonies on the Moon or Mars will be faced with threats from all directions, especially above, where sudden spikes of radiation can turn deadly.
If we were walking around on the surface of the Moon, I would say our number one concern should be solar flare. The sun erupts. The protons coming from that flare could kill an astronaut. There have been several flares over the last couple decades, which if we had had astronauts on the Moon just walking around in a spacesuit would have been lethal for them.
On Earth, we're protected from most radiation. Earth's atmosphere and magnetic field are like a protective fence, letting only a fraction of particles through. On the Moon and Mars, you are directly in the firing line. The Moon has no atmosphere or magnetic field. Mars has very little atmosphere and only weak localized magnetic fields. NASA takes the solar flare threat seriously because it has already come close to killing Apollo astronauts.
The Apollo lunar landing crews were quite fortunate. In 1972, in August, there was a major solar flare. There was what they call the Great Solar Storm that happened to just take place in between the Apollo 16 mission in April and the Apollo 17 mission in December of that year. Had that occurred while there was a crew on the surface of the moon, they would have been dead.